Learners, let's look at the mechanical analytical question that we have here in front of us. You will see that the list or the table of questions is here, and then the drawing component on my left hand side, and there will be answers retrieved from here that will be listed in this column over here. So let's go straight to it. That is basically the instruction that's given to you there. So your first question asks for the date of the drawing when it was checked, and we're going to go down immediately to our title bar and find all of that detail there. Look at checked, Kenneth checked it, and the date below that will be the date that Kenneth checked it. So it is the 2nd of the 10th 2008. So 02:10 and then 2008, or just 8 would suffice as well. Right, in which city is the manufacturing company situated? So we're going to scroll down again, and you're going to find that the city is London, and we are going to put it London in here. Right, and then what is the name of the drawing file? So we're going to go down to our title bar again, and we're going to find that the file name is N-P2E018. So I'm just going to repeat that, N-P2-E018. That's the drawing file number. So the next question reads, how many revisions have been made to the drawing? So that's very important to find this table here. These are the revision dates. You will see the date, change by, who made the change, revision description, and the number. So in this case, there were 2 revisions that were made to this drawing. So 2 is going to be the answer in there. And then, what is the tolerance allowed on the dimensions? Very important. You will find here is a little shaded area where it says unless otherwise specified, tolerances on dimensions are plus minus 0,05. So that is my answer there, 0 plus minus 0,05. How many bolts are required to secure the cylinder head to the body? We're going to go there. You will find that there are holes in here, and those refers to the bolt holes. There they are. When they have been cut, they open. So you're going to count 1, 2, 3, 4, 5, 6, 7, 8, and 8 is going to be your answer. How many surfaces must be machined? By now you should know what a machining symbol looks like. For you who are still unaware of what it looks like, that's basically the machining symbol. So you'll have to count all the symbols that you will see on the drawing here. So I'm going to highlight it. So let's say, because they're hidden all over. So that's 1, that's 2, that is 3, that is 4. You're going to have here 5, and the 6th is hidden there. Then you must just scan all over if you find any of the other symbols in the other views. Nope. So that would be regarded as 6 as your answer of the surfaces which must be machined. Right, number 8. Now we climb a bit to middle order. What is the feature at A called? So we're going to go and find A. So there's A, and A refers to that strip over there that's hatched, and preferably this here. Now because it's a double line, and I also want to make sure that you understand that this is a zoomed in version of that part there. So that part is so small that they actually zoomed in on it and made it bigger. You will find it's exactly the same. So this is a detailed drawing of that specific component there. So if you look at this component, this part here, which A refers to, and you draw a comparison to what it is doing here, it has been screwed in. So that would be screw thread. So we're going to write here screw thread. Okay. What is the feature at B called? We go to B and we find B. It is that slanted little part there. You know it is called a chamfer. That's a chamfer. It's on the corner. What is the feature at C called? So we're going to go to C. C refers to this diamond shape that's all over here. That is going to be a knurling. It's a diamond knurling. But knurling would suffice. So it's a silent K. And your answer is knurling. And then you look at D. What is D called? D is this zigzag component here. You know what it is. If you press down, it has bounce in it. So that is called a spring. So we're going to write spring in here. How many parts does the assembly consist of? So now you've got to count. Okay, you've got to count, and it's very important that you count correctly, right? The amount of parts. I want to zoom in on this component here so that we can count it. So just to show you, so I'm going to start with that U shape here, that's 1, and then I'm going to count this one in as number 2, which is that part there that goes like that there, that's 2. Number 3 is going to be this rod here that has that head. Number 4 is going to be the ball here. Number 5 is the spring that's in here, and it's all screwed into this component that you see here, so that's number 6. So that's 6 components that you are busy with on this analytical question. So we're going to go back here and we're going to write in 6 parts that we are busy with. Okay. What would view 3 be called? That's the next question. So we go to view 3. Now, perhaps you didn't learn this before, so we are going to inform you what it is. If this was cut like it is here, it would have been a removed section, and there was a cutting line here, it would have been a removed section. But in this case, it's not cut, it's not a removed section. This basically shows you what that surface there, that line looks like. So we don't know what it looks like. So a photo was taken from this side here, from that side was taken of that line there, and it was posted like that. So you can see that this reflects that hole there, and then there are holes here which you can't see because that has been cut in the center. So that's the detail of that side there. So this is called an auxiliary view, and I want to spell that for you. So it's A-U-X and I-L-I-A-R-Y, and view, obviously. Okay, auxiliary view, A-U-X-I-L-I-A-R-Y. That's an auxiliary view. Any view that gives you a true version of what the line is here is called an auxiliary view. Normally on the outside here, like that there. Okay, and it's normally in line like that there. Let's go to the next question. Number 14. Name the types of section on view 1 and view 4. So you know that we've got 6 different sections. So we're going to look for specific characteristics of sections. So view 1 is this view over here. Everything has been cut from the left right down to the right side. So it's a full section, and that's your first answer. That is a full section. And if you go to view 4, which is this detailed view here, you only see half of the sectioning in here, the other half still remains intact, so that is going to be a half section as view 4. Okay. Then number 15, determine the dimensions at P, Q, R and S. So we've got to find, let's start with letter P first, and what that answer is for P. Okay. So let's move over and you will find that is where P is, that distance, that gap there, that hole there. So you have to look at your auxiliary view. So if you line this up, you take a ruler and you line this up like that there, and you line that up, you will find it's that circle over there. And if you look specifically at the arrows of that circle there, and you will find the answer right there. Diameter 42, and it's diameter first and then 42. It's important that you must write the diameter in there. So we go to Q. So Q is going to be here, from that point here till that point there. So you won't find the answer there, but you can line it up down like that, where it starts. So it's going to be this inside circle that you see there, and you can check it, the inside circle. In fact, no, Q actually refers to the center, to that center over there. So if you line it up like that, you're going to find from this center point here to that center point over there. And if you look at the arrows, that arrow starts here, it ends there. So we're looking at the 213 PCD. Very important. 213 PCD. You need to write it like that. Okay? So pitch, center, diameter, or pitch, circle, diameter. Any one of those will do. Pitch, circle, preferably pitch, circle, diameter. Okay. And then we go to R. You will find R is that little space that we need a dimension there for. You're not going to find it there. If you scroll over, you're going to see it's 12. So we're going to write in the 12 there. And then we go to S. S is right at the bottom here. S from here to there. You're not going to find the answer there. Now you will have to go and look at where this component actually is screwed in, which is here. So that point from there to there is going to be M33. Okay? M33. Right, next one. What is the angle between holes marked X and Y on the view 1? So you go to view 1, which is there. This is the angle here. There's X and there's Y. So this angle here, without a doubt, you can actually just put your set square in there and you will find that it's a 90 degrees. Or you can take your protractor and put it on like that, and you will find it is in fact 90 degrees. So you're going to write in there 90 degrees. Then the next question, draw the arrows for the cutting plane located in view 2 and label it as AA. Now this is a very important question, because if you look at the view that you need to insert the cutting plane. Now it starts, the cutting plane is there, right? There's another line that looks similar, but it cannot be that line. That line cannot be the cutting plane. Why not? Because a cutting plane, you will be identifying that with a more darker line on the ends here, right? That makes the difference between this cutting line and a center line. If we had taken away those dark pieces there, it would have just been a center line. But now that's a cutting line, and there are dark points on the ends, and you just need to insert the arrows and label it as AA. But which side? For you to remember for the rest of your life, you look at this here. This will guide you, because the cut section is here. We cut this in half, we throw this part away, and we view it from this side like that there. Right? I repeat, you cut this with a grinder in half. This part you remove, that part stays. This part stays. That you remove. So I'm going to take that away. Right? And then you view that from this side and you take a photo from this side and you paste it there. Which basically means if you view it from this side, your arrows are going to go like that against, sort of touching the arrowheads against the line, in the middle of the line, and you're going to label it A. That's very important because that's half a mark, that's half a mark, that's half a mark, that's half a mark. And for the right side, you're also going to get marks for that, right? So it's always, the arrows are always on the side of the line where the cut section is. If this was on that side, these arrows would have just gone to the other side and pointed like that there. So the arrows actually follow where the cut section is. But it actually in reality means that that has been taken away. Okay, we move along. So that has been answered already. What does the symbol that mean? You know, this symbol. You know it's a machining symbol. Right? So it's a machining symbol, so it says machined, so this component has to be machined, so you're going to write there machined, ED, but there's a value that's added here, right? There's a value here. So that is what we call a roughness value, and that value is basically to the level or the depth of the machining that will take place. So machining or machine, and you must write here to a, and I'm going to squeeze it in here, to a value of, and that's going to be 0,02. Okay? Machining or machine to a value of 0,2. That would suffice as an answer. Right? It is actually a roughness value because that shows how rough it is, and it must be machined to a roughness value or a value of 0,2. And then number 19, what orthographic projection system has been used in this particular drawing? For mechanical drawings, for machine drawings, for question paper number 2, which this is all about, it's always going to be third orthographic projection, TOP. It is going to be third, right, which is that there, orthographic, and that's going to be projection that you must have in there. But you can abbreviate it as TOP, third orthographic projection. Okay, you must remember that. And then lastly, our personal favorite, which is the projection symbol. Like I said the last time, you shouldn't get this wrong. You have the given line, you start here with a little line, long line, small circle, small line, big line, connection, and voila, you have that perfectly there as a projection symbol. Now this symbol basically reflects that there, third orthographic projection. This is what the symbol means. Alright, that was brilliant. I hope you enjoyed that one and you've learned a lot about the mechanical features that we have, so that we can ensure that we can tackle the next one even better.